All right, 7th graders, we are in section 4.2, writing equations in point-slope form. So what are you going to learn today? You're going to learn how to write an equation of a line given the slope and a point on that line. You're also going to write an equation of a line just given 2 points and use linear equations to solve real-life problems. All right, now writing equations of lines in point-slope form. Now, given a point on a line and the slope of a line, let's say that again. If you're given a point on a line and a slope on a line, you can write an equation in point-slope form. So, let's say that a line passes through the point, 2, 3, and has a slope of 1/2. Look at what we did here. We took the formula for slope, and look at this. We plugged in slope as 1/2, and we plugged in the value of x and y right here in purple. Now, if I actually solve this, we know that we can cross multiply. So we're going to actually, let's try it like this. We're going to multiply both sides by x minus 2. So if I multiply both sides by x minus 2, these x minus 2's would cancel, and you'd be left with x minus 3, and the other side you'd have 1/2 multiplied by x minus 2. This equation right here is in point-slope form. Y minus 3 equals 1/2 multiplied by x minus 2. But that's why it works. You can take a point and a slope and take the formula for slope and then write your equation. And here it is, your core concept. In words, a linear equation written in point-slope form looks like this. Y minus y sub 1 equals m, your slope, multiplied by the difference of x and x sub 1. The line passes through x sub 1, y sub 1, and the slope is m. So in example 1, we're going to start with an easy problem. I want you to write an equation in point-slope form with a point and a slope. So you remember your point-slope form is y minus y sub 1 equals m multiplied by x minus x sub 1. The point, negative 8, 3, represents x sub 1, y sub 1. So all we do is plug it in. Y minus, what's your y value? 3. Equals your slope, which is 1/4, multiplied by x minus negative 8, which is x plus 8. So in point-slope form, there's your equation. Now in step 2, or example 2, you're going to write equations, but you're not going to be given the slope. You're only going to be given 2 points. So step 1, you got to find the point or the slopes first. So find the slope of both points. So let's do that. I'm going to find the slope. M equals 2 minus negative 2 would give me 4. 1 minus 3 gives me negative 2. Therefore, my slope is negative 2. It goes downhill. It absolutely is negative 2. I am now going to pick any point I want. But notice what the directions say. Write it in slope-intercept form. So I know my slope is negative 2. Now, if I have a point and a slope, notice here we have 2 points. I can pick either one. Let's pick 1, 2. So I'm going to plug that into my equation. Y minus my y value equals your slope multiplied by x minus your x value. Now I have to simplify this. Y minus 2 equals negative 2x plus 2. I then add 2 to both sides. That gives me negative 2x plus 4. Now you may be saying, Mr. Humphreys, but wait a minute. There's another point. Can I use the other one? Let's see. y minus, here's my y value, minus 2. So y minus negative 2 gives me y plus 2 equals my slope multiplied by my x value, which is 3. So x minus 3. I now distribute. That gives me negative 2x plus 6. I then subtract 2 on both sides. And that gives me negative 2x plus 4. Notice that you're going to get the same answer no matter which point you use. Try this one on your own. Example 3. Write a linear function with the values f of 4 equals negative 2 and f of 8 equals 4. Pause the video and try to do that. Alright, if you did it correctly, we'd have the points 4, negative 2 and 8, 4. If I found my slope, let's see, negative 2 minus 4 is negative 6. 4 minus 8 is negative 4. That gives me a positive 2/3 slope. That is not positive 2/3 slope. That is positive 3/2 slope. So 3/2. And I'm going to pick 8, 4. So y minus my y value equals my slope multiplied by x minus 8, my x value. So what do I want to do? Well, I can distribute. So that gives me 3/2 or 1.5 x. 3/2 times negative 8, let's see, that'd be negative 12. I then add 4 to both sides. And now I have to make it a function. F of x equals 3/2 x minus 8. And there's my function. All right, our last example. The student council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. Can the situation be modeled by a linear equation? Explain, if possible. Write a linear model that represents the cost as a function of the number of foam hands. So, first off, we have to make sure that the rate of change for all consecutive data pairs in the table is constant. So let's look at my x value. This goes up by 2, goes up by 2, goes up by 2, goes up by 2. So my x value goes up by 2 every time. So my change in x is 2. Now my change in y, cost in dollars. 34 to 46, that goes up by 12. 12, 12, 12. So my change in y is 12. Therefore, my slope is 6. Now, in this problem, we have to write a function of cost. So C equals number of foam hands. So we're going to use n for the number of foam hands. We know it's 6x. So now, I need to figure out what b is, or what your y-intercept is. But remember, I have the slope. I have a point. You can pick any point you want. I'm going to pick the point 434. So I'm going to plug this in. So y minus 34 equals m multiplied by x minus x sub 1, which is 4. So that gives me y minus 34 equals 6x minus 24. I add 34 to both sides, and negative 24 plus 34 is plus 10. So my function is c equals 6x plus 10. Now, if I asked you to interpret what these meant, this means that it would cost $10 even if you didn't buy any foam hands. And that may be like a setup fee. And then every additional foam hand is going to cost $6. So that would be interpreting what these numbers mean.